Banana stems don't become leather by tanning the way animal hides do. They become leather-like sheets by turning a wet, fibrous agricultural byproduct into a controlled composite with a textile backbone and a high-performance surface. In a luxury factory, the word leather is really describing the end-use properties: grain, hand feel, stitch holding, abrasion resistance, and color depth, because those are engineered, not inherited from skin. The raw material starts as banana pseudostem, the layered trunk left after the fruit is harvested. It's mostly water and cellulose, and if it sits too long, it starts to ferment. So the first requirement is speed and cold chain thinking without refrigeration, quick collection, fast transport, and rapid processing. Incoming stems are weighed and lot traced because fiber quality varies by variety, climate, and maturity. And a premium surface can't hide inconsistent fiber length or contamination. The first mechanical step is decortication, which is industrial peeling and scraping designed to extract long bast-like fibers without chopping them into fuzz. Continuous decorticators pull stem strips through feed rollers while rotating beaters and scraper plates strip away pith, leaving fiber bundles. Pressure control is everything here. Too much force cuts fibers and lowers tensile strength. Too little force leaves pith that later causes odor, discoloration, and weak bonding with resins. Right after extraction, the fiber is saturated with sap, sugars, and gummy compounds that attract microbes and interfere with coatings. High-throughput lines wash fibers using countercurrent spray bars and agitation. Tanks to remove sugars and fines while minimizing water use. Screens separate long fibers from short fragments. And hydrocyclones can pull out heavy grit that would otherwise destroy carding wires and emboss rollers downstream to make a luxury sheet. The plant usually performs deguming because raw banana fiber is stiff and irregular. Deguming can be enzymatic, alkaline, or hybrid, and it's run like a controlled chemical process. Temperature, pH, and residence time are monitored, because overprocessing weakens the cellulose and underpressing leaves harshness and poor dye response. After deguming, neutralization and multiple rinses prevent chemical carryover that could later attack adhesives or cause
thins, edges, and folds to the precise thickness. Check with a micrometer gauge.
Premature hydrolysis and polyurethane coatings. Drying is one of the biggest energy and quality choke points, because wet fiber won't form consistent webs, and it can mold in storage. Instead of blasting high heat that makes fibers brittle, modern plants use stage drying. Mechanical squeeze presses first. Then belt or conveyor dryers with humidity control. Inline moisture sensors keep fiber within a tight band, because too dry increases breakage during opening and carding, while too wet destabilizes web formation and invites microbial growth. Now the process shifts from fiber production to material engineering, because wallets require a sheet that behaves like leather under bending and stitching. The fiber is opened and individualized through bale breakers and opener lines, then carded to align fibers and remove remaining trash. The carding stage is where the sheet's strength starts. Longer, better line fibers create higher tear resistance, and that tear resistance is what prevents a wallet corner from ripping at the stitch line over years of flexing. The factory then forms the fiber into a web and bonds it into a non-woven. Needle punching is common because it mechanically entangles fibers with barbed needles, building thickness and strength without heavy binders. Hydroentanglement is another option for softer hand feel, using high-pressure water jets to tangle fibers into a cleaner, more textile-like base, but it requires advanced water filtration and recirculation to stay economical. For luxury leather hand feel, manufacturers often choose a dense needle-punched base, then tune softness later with impregnation and finishing at this stage. The material looks like felt, not leather, and it still lacks the critical properties wallets demand: low linting, smooth surface, water resistance, and a stable grain.
Reinforcement and structural construction.
Applying liners, stiffeners, and reinforcing materials to areas requiring shape reform.
That's where impregnation comes in. The non-woven passes through a saturation bath or knife overroll station that introduces a binder, often a water-based polyurethane. bio-based resin blend, or latex system then, through nip rollers that control Adon percentage. Adon is measured by weight gain, because too little binder leaves a weak, fuzzy surface, and too much binder makes the sheet plasticky, heavy, and prone to cracking at fold lines. Curing is controlled as tightly as cooking in a food plant. Drying ovens drive off water or solvents, and temperature ramps are chosen to avoid skinning, where the surface cures too fast and traps volatiles inside. Trapped volatiles cause bubbles, weak adhesion between layers, and odor issues that show up later in sealed packaging. Premium operations use forced air ovens with zone temperature control, and they log time temperature profiles to keep batches consistent. With the base stabilized, the sheet is calendared compressed between heated rollers to tune thickness, density, and surface smoothness. Calendaring changes the way light reflects off the surface and the way the sheet takes embossing. It also affects stitch performance, because a denser sheet holds thread tension better and reduces the risk of stitch pull-through. At stress points like card slots, the leather-like surface is built with coating and lamination, and this is where the factory earns the luxury label. A typical structure is a banana fiber, non-woven core, optionally laminated to a backing fabric for dimensional stability, then coated with a polyurethane system that provides the grain, color, and protection. The coating may be applied as a base coat for adhesion and leveling, a pigmented layer for color, and a top coat for abrasion and stain resistance. Many high-end facilities prefer water-based PU to reduce VOCs and meet stricter indoor air and worker exposure standards. But water-based systems still demand precise drying control to prevent pinholes and blushing. Embossing creates the grain pattern. Heated emboss rollers press a texture into the coating under controlled pressure and temperature. If pressure is uneven, the grain depth varies across the roll, and that inconsistency becomes obvious on small wallet panels where every piece sits side by side in a retail display. Roller temperature also matters because it affects flow and memory of the coating. Too cool, and the grain won't set sharply. Too hot and the surface can gloss, smear, or thin at the peaks, reducing wear resistance. Color is engineered in layers, not sprayed as a single finish. Pigment dispersions are milled to controlled particle size, so color looks deep without chalkiness. And crosslinkers may be used to improve chemical resistance against hand oils, sanitizer, and dye transfer from denim. Premium lines often add effect, layers matte, satin, or semi-gloss by tuning topcoat chemistry and microtexture, because luxury is as much about touch and light behavior as it is about durability. A banana stem-based leather also needs controlled stretch. Wallets must be stiff enough to keep shape, but flexible enough to fold repeatedly without cracking. That balance is achieved by adjusting non-woven density, resin, Adon, and coating modulus. The factory verifies this with flex testing, abrasion testing, and tear resistance measurements, because a wallet fails first at fold lines and corners, not on a flat panel. One of the most important quality gates is hydrolysis and heat aging performance. Polyurethane systems can degrade in humidity and heat if the chemistry isn't right, so plants run accelerated aging tests and check for tackiness, cracking, and delamination. Adhesion testing is also critical because if a coating peels from the fiber core, the product is finished no matter how good it looked on day one. Once the sheet passes finishing, it moves into converting, where leather-like material becomes wallet parts with almost no tolerance for dimensional drift. Rolls are conditioned to a target humidity and temperature, so the sheet doesn't expand or contract after cutting. CNC cutting tables use oscillating knives for clean edges, and die cutting is used for high-volume styles because a steel rule die delivers repeatable geometry at speed. Some factories use laser cutting for small details, but heat can seal edges and change color. So laser parameters have to be tuned for each coating system. Asterisk. Material utilization is tracked like any other high-value manufacturing process. Nesting software arranges wallet patterns to maximize yield from each roll while keeping grain direction consistent. Because even a synthetic grain has a visual flow that affects perceived quality. The factory also separates panels by defect mapping. Camera inspection can mark tiny coating flaws, pinholes, or emboss inconsistencies, and the cutter avoids them automatically to protect. Premium grade output. Wallet construction begins with reinforcement and lamination steps. Card slots and spine areas may receive thin stiffeners, often recycled polymer sheets or fiberboard, bonded with heat-activated films or water-based adhesives. Adhesive choice is not cosmetic. It affects flexibility, odor, VOC compliance, and resistance to delamination when the wallet is left in a hot car. Bond lines are pressed under controlled pressure to prevent bubbles. Because bubbles become visible, telegraphing under a thin luxury surface, edge finishing is where low-end products reveal themselves. So luxury lines treat edges as a separate manufacturing process. Edges are skividate, fold points using skiving machines that shave the composite to a consistent taper, reducing bulk and improving fold behavior. Edges are then painted with flexible edge coatings in multiple layers, with drying between coats to create a smooth, sealed perimeter that resists fraying and moisture ingress. Stitching is engineered around thread, needle geometry, and stitch density. Industrial sewing machines run with consistent tension and stitch length so seams sit flat and don't pucker the material. Needle selection matters because punctures are permanent. Too large a needle weakens the composite and creates visible holes. Too small can cause thread abrasion and breakage. Reinforced lock stitches are placed at high stress points, and bar tacks may be added, or card slots see repeated pull forces. Hardware is installed with controlled force because composite leathers can crush if overpressed. If a wallet includes snaps or rivets, pneumatic presses set them with calibrated stroke and anvil geometry to distribute load. Metal parts are often plated and tested for corrosion resistance, because hand sweat is chemically aggressive over time. Final forming and inspection are not just a visual check. The factory verifies fold symmetry, slot fit, and seam strength with pull tests and flex cycles. Surface inspection checks for gloss uniformity, grain consistency, and color match under standardized lighting because retail lighting can exaggerate differences. Packaging is designed to avoid imprinting the surface. Soft tissue wraps and controlled stacking prevent pressure. Marks that can set into a freshly cured coating. The banana stem claim also has to survive documentation. Premium operations maintain chain of custody records linking material back to fiber batches and finishing lots, and they verify restricted substances for export markets. If the product is sold as a sustainable alternative, audits and lab tests often confirm bio-based content, VOC levels, and compliance with chemical restrictions. Because luxury brands can't afford compliance failures, what makes this process high-tech is that it turns an agricultural residue with massive natural variability into a repeatable, luxury-grade material by controlling structure at every scale. Fiber length and cleanliness are controlled in extraction and washing. Strength is built in non-woven formation. Flexibility and durability are tuned through impregnation and coating chemistry. And the final aesthetic is manufactured through embossing and multi-layer finishing. By the time a banana stem becomes a wallet, it's no longer just plant fiber. It's a precisely engineered composite designed to look premium so cleanly flex for years, and deliver the tactile experience people expect from luxury leather goods without relying on animal hide.